many of the algorithms that are shaping our lives are the ones you don't see, right? So the callback you never get because your resume is screened out by a hiring system.
We came here today to talk about this thing that has been a big topic today, algorithms and AI, and I want to welcome Dr. Joy and Kyle to talk to me. How's it going?
Thank you.
Hello.
Let's talk about algorithms. Let's actually have a definition. So talk to me like I'm on that subreddit, talk to me like I'm 5. What is an algorithm?
To me, an algorithm is just a sequence of steps to achieve an outcome. So for me, I loved video games. I used to love playing Tony Hawk's Pro Skater too.
Mine's like Donkey Kong Country. That was a beautiful game.
Right.
And played that in the 90s.
We could just do Tony Hawk and Donkey Kong for another half hour.
We just talk about those two
Excellent
games
panel.
were really, really good. Anyway, continue.
Right. So you want a character to move left, you have this input, this action happens. And so that gets you that early introduction to what is our language to communicate with computers so that we can program them or shape them to help us express ourselves, solve problems, and so forth.
Yeah, and Kyle, you have your whole first chapter is going through what is an algorithm, how long have they been in history and human, civilization. So can you add to maybe a different definition of algorithm?
Yeah, I mean, as Dr. Joy said, in a literal sense, it's like an equation. So if you go back millennia, there are, I think it was the Babylonian kingdom or something.
1800 BC.
Yeah, and there are equations for finding the volume of dirt that you dug out of a ditch, or how to split up, a crop, or share things between people. And so these were just basic equations, step-by-step mathematical processes to find a result that was a desired result. And I think that it's funny because now when we talk about the algorithm or algorithms in general, it's a kind of boogeyman or an omnipotent deity or something.
Yeah.
But so many of these experiences, whether it's face detection or your recommendations in your Facebook feed, they do come back to these equations that are just taking in variables, on Facebook, things like likes or what you've clicked on before or what other people similar to you have clicked on. And they're crunching all of that data and then determining a result. And that's kind of what we're facing in technology.
There's also, I remember reading that a cooking recipe is an algorithm, right? Because it's directions on what to do and having an input and an output, right? So is there any, other than the technology we talked about, any other kind of examples people can think about algorithms in everyday life?
Well, I think about the algorithms they use in the healthcare system, right? Determining who has access. Triage can be an algorithm, and it might be one that you may or may not see. So even though the work that I do, a lot of people know is around facial recognition technologies, many of the algorithms that are shaping our lives are the ones you don't see, right? So the callback you never get because your resume is screened out by a hiring system.
Wow, I like that visual. Let's go from algorithms to artificial intelligence, AI. So how do we go from software solving problems, calculations like Kyle talked about, to software that thinks for itself? And Dr. Joy, I'm gonna let you break down the difference between we're just talking about algorithms and now we're talking about AI.
Got it. And also thinks for itself is interesting.
Yeah. Well, we have it in quotes here because my boss was put it in quotes. Thinks for itself. We'll talk about hallucinations in a second.
Sure.
Yeah.
So when I think about AI, I approach it as this ongoing quest to give machines abilities we associate with intelligence or humans, right? So whether it's recognizing a face, a puppy, or making a prediction, are you going to pay back that loan? Are you going to be a good tenant? Are you going to be a good student? These are the types of applications we're seeing with AI. How I think about AI somewhat differently than some of the earlier algorithms you're talking about with these direct equations. Once you start trying to approach human kind of intelligence or problem solving, computer scientists like me, we quickly realize you're not going to be able to put out all of the instructions.
Right.
It's messy, it's complicated, there are always exceptions, right?
Yeah.
And so you see these earrings that I'm wearing, they're on the book, and they're actually a shape of a neural network. And so the neural network was this idea of, can we learn from the human brain, right? And maybe we can imitate the human brain, not making it conscious, but saying maybe we can create pattern recognition systems. So instead of having to code everything line by line, maybe instead we can present a data set of examples, so a data set of faces. That's how you would train a machine to learn, hence machine learning, as a kind of flavor of artificial intelligence.
Yeah.
And so now you have these pattern recognition algorithms that are trained on a data set, and then it means the quality of that data set is going to determine the quality of your outputs.
Everyone turn on your facial recognition block. We're here to make a plan and can't nobody stop. Everyone turn on your facial recognition block. We're here to make a plan and can't nobody stop. Everyone turn on